Coral bleaching, how it works, and the role humans play in it. To understand coral bleaching, let's take a trip to one of the most heavily studied sites of mass coral bleaching happening in the world today, the Great Barrier Reef. Located off the coast of Queensland, Australia, the Great Barrier Reef provides Australia's economy with more than $5 billion annually, and greater than 60,000 jobs in tourism, simply by attracting divers and snorkelers like this one. Lately, rather than witnessing the reef's typical vibrant colours, snorkelers have been seeing a reef dominated by fluorescent white corals. So, what's really going on here? The Earth is heating up as a result of the excess carbon dioxide we put in the atmosphere by burning fossil fuels, driving cars, and doing a number of other things. We call this global warming, and as the name suggests, it raises water temperatures around the world, but most notably in the tropics, where you can find the world's coral reef ecosystems. Let's take a closer look at the reef. An even closer look than that. See, each individual coral that makes up the reef is colonial, made up of hundreds of its own smaller organisms called polyps. Though technically animals, corals get their energy from the sun, much like plants, but they can't do it without the help of these little guys inside them. These are symbiotic algae called zooxanthellae, but if you want to talk like a real marine biologist, you'll call them zooks. Think of coral as a hotel for zooks. The more customers the coral has boarding in its room, the more its hotel business thrives. But what happens when the customers' rooms get too hot? Well, they check out, of course. No one likes a boiling hotel room with no temperature control. Without its customers, hotel coral can't stay up and running and is eventually forced to shut down. This departure of the zooks from the coral is what scientists know as coral bleaching. Because without the zooks to literally put the color in their lives, the corals turn white. It's not long before this continued lack of business, this bleaching due to the heat, results in the death of the coral. But we'll consider bleaching the stage that comes just before it's too late. Now, let's take a look back at the reef. Each coral plays an important role in the reef community, providing shelter and food, much like a hotel provides jobs for its community members. But what happens when all the hotels in this area shut down due to a heating problem? Without any business, the whole community suffers, and everyone, including the fish, are forced to pack up and leave. This, in turn, affects business in the human economy, because without healthy coral to take care of our fish as they grow, there's a lot less of them for fishermen to catch. And there's lots less snorkelers who want to pay more money just to see a boring white reef. So I bet you're wondering at this point, how on earth can we fix this? Well, nature may just have a solution of its own. One scientist likes to call the adaptive bleaching hypothesis. Turns out, a certain kind of zoox, known as clade D, loves the heat. They don't mind moving into a hot room at all. And with their business, hotel coral can once again be up and running. With all these heat-tolerant zooks, the corals get to cheat death and return to a life of color. Not all the corals in the reef are fortunate enough to get this business. Only certain species have exhibited this rebound so far, and scientists aren't sure of time frame behind it, but it does offer us some hope that the reef can be saved. In the event that nature can't recover on its own, there are some things that we humans can do in the meantime. We can each minimize the amount of carbon we put into the atmosphere, otherwise known as our carbon footprint, by driving our cars less and using smaller amounts of electricity. Or we can influence the fossil fuel industry by voting for policies that promote a switch to renewable energies like solar and wind power. Although this is our best bet, if it's not enough, we may be able to geoengineer a solution to our warming reefs. One of the ways in which we can do this is by 3D printing coral out of sand and placing the artificial replicas throughout the reef. This gives the reef more structure, which serves to enhance coral growth by providing the essential nooks and crannies that baby coral polyps love to settle on and begin growing. Test runs have showed us promising results. Another geoengineering solution is to mechanically pump cold water from deeper depths up to the shallows to mix with the warm water on the reef. This idea was inspired by the natural upwelling of cold water at certain healthy reefs in Guam and in the Caribbean. So now we know how coral bleaching works, what it means for the fishermen and the ecotourism companies, and that there are solutions which offer our bleaching reefs some hope for the future. With over 90% of just the Great Barrier Reef suffering from coral bleaching today, there is no time like the present to put these solutions into action.